Hello, good morning to all of you. The organic chemistry. Today we are going to start the stereochemistry second topics. The first point of this topic is stereoselective reactions. This is a special types of reactions in which one of the stereoisomers is mainly formed is called as stereoselective reactions. For example, consider one reactions in which we will get the two enantiomeric products. These two products are of enantiomer of each other, in which one of the is major mainly forms as a product. These types of reactions are stereoselective reactions. So the reactions in which the product has many stereoisomers, but one of the stereoisomers selectively or mainly formed is called as stereoselective reactions. Stereoselective reactions are of two types. One is the enantioselective reaction, another is the diastereoselective reactions. For understanding the better, we have the one video also.
Move on to the next topic, enantioselective reaction. What is an enantioselective reaction? When a process such as a chemical reaction or a chemical conversion or total synthesis that produces a single enantiomer of a substance, then the reaction is enantioselective in nature. In this example, the ketone on reduction with alpine boron is enantioselective because it produces only one of the two possible enantiomer exclusively, which is R or S. On the other hand, the reduction of the same ketone with sodium borohydride in isopropanol is not enantioselective because it produces a racemic mixture of both possible alcohol enantiomers. So to make it simple, when we end up with only one enantiomer, we call the reaction as enantioselective in nature. Enantiomeric excess is a factor that helps us to identify the percentage of one enantiomer over the other. The excess of one enantiomer over the other in a mixture of enantiomer is expressed mathematically as enantiomeric excess is equal to percentage minor enantiomer. For example, if a mixture is composed of 86% R and 14% S enantiomer, then it has an enantiomeric excess of 86 minus 14, which is 72%. It is expressed as EE. When a substance is a single pure enantiomer, it has an enantiomeric excess of 100%, which is called homochiral or optically pure. In this particular reaction, we end up with R enantiomer, which is 90% of the product mixture, and S enantiomer, which is 10% of the product mixture. The product of this reaction, one possible step in the manufacture of naproxen, an analgesic, is a mixture of 90% S and 10% R, and the enantiomeric excess is 80%. The reduction of acetophenone with sodium borohydride confirmed that an achiral hydride reducing agents cannot react in an enantioselective manner, and it is a research article published by Hydride with a chiral alcohol gave a modified chiral reducing agent which is capable of reducing acetophenone enantioselectively. So when acetophenone is reduced using lithium aluminum hydride, we end up with 50% of S isomer and 50% of R isomer, and here the enantiomeric excess is 0%. Whereas when a chiral modified lithium aluminum hydride is used, one of the isomer predominates and we end up with an enantiomeric excess of 68%. Although the method is simple, it should be noted that the enantio selection 68% is not ideal in a practical sense because of the difficulties associated in purifying, that is resolving the product in order to obtain a single isomer. Let us move on to our next topic, diastereoselective reaction. When a process such as chemical reaction or chemical conversion or total synthesis that can produce a mixture of diastereomers, but only one of these diastereomers are major product, then the reaction is diastereoselective in nature. In this particular example, when dimethyl cyclohexane is treated with bromine, we end up with anti-addition product, which is the only product formed, whereas the syn addition product is not formed. So addition of bromine to 1,2 dimethyl cyclohexane is diastereoselective because anti-addition is the only pathway and only a single diastereomer of the product is formed. Addition of HBr to 1,2 dimethyl cyclohexane is not diastereoselective because the product is a mixture of nearly equal amounts of the two diastereomers.
So in our notes, systematically representations of the notes are given here. In these notes, the point to point given here, the video is for your understanding only. The points for the remindations is here. In that first point is a reaction which gives the predominantly one enantiomer of a set of possible enantiomer is called as enantioselective reactions. Since one of the enantiomer is formed in excess, so it is called as enantioselective reactions. Example, consider the SN2 reactions. Consider the SN2 reactions at asymmetric or chiral carbon. If one of the enantiomer is used in the particular enantiomer of the product is selectively formed. So this type of reaction is called as enantioselective is given here. Plus octane to all, one of the enantiomer is formed. When LiVo is treated with the base, only dextro 2-octane is formed. Similarly, dextroisomers gives the LiVo products. This is an example of enantioselective reaction. Since one of the enantiomer is formed is excess, so it is called as enantiomeric excess. In the next lecture, we will discuss the diastereoselective reactions.